Hi everyone, I am the founder of the Grey Blind Owl. Today we will learn data types and variables in this sample code. I am going to explain our topic with comment lines. After that, we are going to write a simple code to be clear. Comment lines is not important for the compiler. We use them to leave small notes so that other developers can easily understand our code or to understand an old program ourselves in the future. However, I use them to provide educational information other than their normal purposes. We can create comment line with these methods: slash, star, multiple comments, star, slash, or slash, and single comment. Variables. Variables are your keywords. Actually, they are your special words that keep the datas. You can give a name that you wish to them, but you must be careful about these rules. There is no space in any variable name. If you want a space, you can use underscore. For example, data type, temperature, underscore, value, semicolon. Data type, temperature, underscore, value, semicolon. They should be short and understandable. This is not critical, but if you look at your code later, you may not understand your code even if you use the comment lines. They may seem confusing. Data types. We have a lot of data types, but I want you to focus on integer, float, and char types for now. Integer, float, and char types. Other data types are not critical for the beginning. I will mention them in the following codes. Do not worry about them and their detailed informations. They are important for the storage and efficiency management, but now our codes are very simple and we do not have to think about that. We will change our habits in the future, but not today. Firstly, we must understand the main logic. Integer type. We always use integer type for the integer numbers. It can save the integer numbers between this number and this number. Usage, integer, variable name, and semicolon. In multiple way, integer, variable 1, comma, variable 2, comma, variable 3, comma, and semicolon. 32-bit required for the integer type. Bit is the most smallest storage component of our computers. Every 1 and every 0 in the machine language requires 1 bit. However, we generally see the bytes in our computers, and 1 byte is equal to 8 bits. We will use $D or $I for the integer type. I will explain this in the main code. Float type. We always use float type for the float numbers. It can save the float numbers between this number and this number. Usage, float, variable name, and semicolon, or float, variable 1, comma, variable 2, comma, variable 3, comma, semicolon. 32-bit required for this again, and we will use $F for the float type. Char type. We generally use char type for the ASCII table characters in our language for letters and some specialized characters. You can reach the ASCII table with this URL. I will share it in the description. Nevertheless, do not think char type only for the characters. You can keep the integer numbers between negative 127 and positive 127 in the char type. Usage char, variable name, and semicolon, or char, variable 1, comma, variable 2, comma, variable 3, comma, semicolon. 8-bit required for the char type, and we will use %sign C for characters and %sign D or %sign I for integers in the char type. I will give you the other data types. The data types I mentioned above are the main types that we must know. Now I will give you the optional types. First one is short type. We always use short type for the mid-integer numbers. The main difference between the integer and short types is that the short type can save the integer numbers between this number and this number. You can say this is unnecessary. Integer type can save more integer number. It is natural. However, if we do not work with big integer numbers or our program does not need the big numbers as an absolute value, short type would be better to use. Because integer type needs more bit than the short type. 16-bit required for the short type, as you can see, and integer type needs more bit than the short type. Usage short, variable name, and semicolon, or short, variable 1, comma, variable 2, comma, variable 3, comma, and blah blah blah, semicolon. We will use %sign D or %sign I for short type. Unsigned short type. We always use unsigned short type for the only positive mid-integer numbers. The main difference between the short and unsigned short types is that the unsigned short type can save the only positive integer numbers up to this number. If you need the only positive integer numbers in your program and if you do not need the integer type, you can use the unsigned short type. Usage, unsigned short, variable name, and semicolon. Or unsigned short, variable 1, comma, variable 2, comma, variable 3, comma, semicolon. 16-bit required, again, and we will use %sign D or %sign I for the unsigned short type. Unsigned int type. We always use unsigned int type for the only positive integer numbers. The main difference between the integer and unsigned integer types is that the unsigned integer type can save the only positive integer numbers up to this number. If you need the only positive integer numbers in your program, you can use the unsigned integer type. Unsigned integer, variable name, and semicolon, or unsigned integer, variable 1, comma, variable 2, comma, variable 3, and semicolon. 32-bit required for the unsigned integer type, and we will use %sign D or %sign I for the unsigned integer type. Long type. We always use long type for the very big integer numbers. It can save the integer numbers between this number and this number. If you need very big integer numbers like in a scientific program, you can use the long type, and usage long, variable name, and semicolon, or long, variable 1, comma, variable 2, comma, variable 3, and semicolon. 64-bit required for this type, and we will use %sign d or %sign I for the long type. Unsigned long type. We always use unsigned long type for the very big positive integer numbers. Very big positive integer numbers. It can save the positive integer numbers up to this number. If you need very big only positive integer numbers, you can use the unsigned long type. Usage, unsigned long, variable name, and semicolon, or unsigned long, variable 1, comma, variable 2, comma, variable 3, comma, blah blah blah, and semicolon. 64-bit required for this type again, and we will use %sign d or %sign I for unsigned long type. Double type. We always use double type for the very big float numbers. It can save the very big float numbers between this number and this number. If you need very big float numbers memory, especially a program consists of very sensitive data, you can use the double type. Usage, double, variable name, and semicolon, double, variable 1, comma, variable 2, comma, variable 3, comma, blah blah blah, and semicolon. We will use %sign F for the double type and 64-bit required for the double type. Unsigned char type. We always use unsigned char type for the small positive integer numbers. Very small positive integer numbers. It can save the very small integer numbers up to 255. If your program needs only very small positive numbers, you can use the unsigned char type. Usage, unsigned char, variable name, and semicolon, or unsigned char, variable 1, comma, variable 2, comma, variable 3, comma, blah blah blah, and semicolon. 8-bit required for this type, and we will use %sign d or %sign I for unsigned char type. And the string type. I do not explain this type of data in this code. You will meet with this type in the following codes. String type keeps a text for you. Therefore, you can take a text from the user with this type. However, we need to know arrays for this, and now it is early for you. 8-bit required for every character in your string, and we will use %sign S for the string type. Okay. Firstly, we will compile and run our program. After that, we will check the code and check the output. Execute, compile, and run. As you can see, our output is here. Okay. We will include our library, hashtag, include, bracket, stdio.h, bracket. And we will create our main function, integer, main, brackets, and the curly brackets. After that, we will print integer variables on the screen, like that, integer variables. Printf, bracket, quotes, integer variables, /n, quotes, bracket, and semicolon. /n means, hey compiler, please go on with the next line. Okay, go on with the next line. Here, integer variables, and first at the next line. Integer variables, inverse slash n and the next line. Okay, now we will define some integer variables. This is the direct method. Integer 1 is equal to 5 and semicolon. Printf bracket quotes first is equal to $d inverse slash n quotes comma integer 1. So I call the data type here. $d related with integer 1. The $d is related to integer 1. So we will see on the screen integer 1. First is equal to integer 1. So 5. Here. Okay. This is the direct method. Now this is indirect method. We will create our variable here, integer 2 and semicolon, and we put a value into this variable at the next line. Integer 2 is equal to 5 semicolon, and we will print it like that. As you can see, second is equal to 5. Now multiple definitions. Integer multiple 1 comma integer multiple 2 comma integer multiple 3 comma integer multiple 4 and semicolon. Now I put the values into our variables. Integer multiple 1 is equal to 6 semicolon. Integer multiple 2 is equal to 7 semicolon. And integer multiple 3 is equal to 8 semicolon. Integer multiple 4 is equal to 9 and semicolon. And I will print it. Third is equal to $d is related to integer multiple 1. Fourth is equal to $d is related to integer multiple 2. Fifth is equal to the $d, and this is related to integer multiple 3. And sixth is equal to $d, and it is related to integer multiple 4 and semicolon. As you can see, third is equal to 6, fourth is equal to 7, fifth is equal to 8, and sixth is equal to 9. Okay. Float variables. Printf float variables. We are here. Indirect method float 1 is equal to 3.2 and semicolon, and we will print it. Printf bracket quotes first is equal to the sign f float 1. So we will see 3.2 here. And in the indirect method, float 2 and semicolon, we defined it, and we will put a value into our variable. Float 2 is equal to 3.2 and semicolon, and we will print it like that. And as you can see, second is equal to 3.2. And multiple way, float multiple 1 comma float multiple 2 comma float multiple 3 comma float multiple 4 and semicolon. Float multiple 1 is equal to 6.44, and float multiple 2 is equal to 7.55 and semicolon. float multiple 3 is equal to 8.66 and semicolon. Float multiple 4 and it's equal to 9.77 and semicolon. Okay, we will print them. Printf third is equal to the person sign dot to f. Okay, there's a difference between the integer numbers. Okay, as you can see, you see 2 digits here. Not a lot of 0, only 2 digits here. If I the person sign dot to f, if I use this, you can see like this. If I use dot 3f like that, you can see 3 digits after the point. If I use dot 4f, you can see 4 digits. And if I use dot 5f, you can see 5 digits here. Okay? So, I print them. Now, char variables. Char variables. We are here. Char variables. Indirect method, char1 is equal to quote a quote and semicolon. Printf first is equal to the person sign C and char1. We will see a letter here. First is equal to a letter. So in the indirect method, char2, we defined it and we put the value into our variable. Char2 is equal to quote a quote semicolon and we print it. As you can see, second is equal to a. In multiple way, char multiple 1, char multiple 2, char multiple 3, char multiple 4 and semicolon. Char multiple 1 is equal to quote C quote semicolon. Char multiple 2 is equal to quote D quote semicolon. Char multiple 3 is equal to quote E quote semicolon. And char multiple 4 is equal to quote F quote and semicolon. Printf third is equal to the person sign C and it is related to char multiple 1. Fourth is equal to person sign C and this is related to char multiple 2. Fifth is equal to person sign C and this is related to char multiple 3. And sixth is equal to person sign C and this is related to char multiple 4. As you can see, third is equal to C, fourth is equal to D, fifth is equal to E, and sixth is equal to F. We will not continue our topic with simple operators. I will share this code with you in the description section, and if you wish, you can review the operators which we will start next lecture. Next lecture, we will continue with operators and interactive programming. Until then, I would like to ask you to define your own variables in a blank code page, insert values into them, and print them to the screen. Thanks for your effort and patience. See you next lecture. Stay tuned.